Hello everyone, welcome to my YouTube channel. In this video, we'll be building a REST API with Node.js and Express. Specifically, we'll be building a Movies API. We'll start by discussing what is a REST API. A REST API is an application programming interface that conforms to the constraints of REST architectural style and allows for interacting with RESTful web server. Maybe difficult to understand, right? Think of this as the director that guides communication between different applications. It allows seamless integration and data exchange. So why is Node.js? It's actually a rockstar actor in the industry of server-side development. With its fast, event-driven architecture, Node.js lets us handle a large number of requests and build highly responsive APIs. Plus, it lets us use JavaScript on server side, which is the great thing. Now let's talk about CRUD, which stands for create, read, update, and delete. These are the basic operations for interacting with data in a persistent storage system. So let's stay tuned and let's get started. To begin setting up Node.js in Visual Studio Code, we start by visiting the official Node.js website. I have conveniently provided a link below this video description. There you can explore the latest version of Node.js or for recommended version, depending on your preferences or project requirements. Once you have downloaded Node.js, it's time to switch to Visual Studio Code or your preferred IDE. Open Visual Studio Code and create a new folder for your project by selecting REST API or any name of your choice. Next, let's set up the terminal in Visual Studio Code. Locate the navigation bar and click on New Terminal. This will open the terminal, providing a command line interface for running various Node.js commands and scripts within your project. With Node.js now installed and Visual Studio Code configured, we're ready to dive into the exciting world of the server-side JavaScript development. To initialize our backend JavaScript application, we will run the command npm init in the terminal. This command prompts us to provide various details, including the package name, version, entry point, test command, git repository, keywords, author, and license. After executing the npm init command, a package.json file will be created. This file acts as a central hub for manage various aspects of your project, including dependencies, script, and metadata. To enhance our project with power and convenience of Express framework, we need to install it npm i Express. Express is a more popular framework for Node.js, enabling us to build robust web applications efficiently. It's important to note that Express is a framework, not a necessity for basic server-side development in Node.js. However, by using Express, we can streamline the creation of different routes within your application, saving time and improving code readability. To add Express as dependency, open the package.json file. Note that it automatically adds the Express package as a dependency object after you install it. Now in index.js file, we can import Express by writing const express equal require express. Alternatively, if you prefer using ECMAScript modules, you can add a new property type module to the package.json file. This allows you to import Express using the syntax import Express from Express. By following this step, We can set up our Node.js environment, create the initial files, and integrate the Power Express framework into our project. To create our first server using Node.js and Express, we start by initializing our Express application with the following code: const app equal express. Here we call the express function, and the side returns value to variable app. This allows us to access and configure our application through the app variable. By encapsulating our entire application within a single variable, we can easily manage its routes, middleware, and other figure in the structure and organized manner. The next step is to specify the port on which our server will listen for incoming requests. We accomplish this by declaring a constant variable named port and assigning it a value of 3000. It is essential to note that the choice of the port number is not fixed, and you can use any available port according to your needs. However, conventionally, developers often use localhost 3000. Finally, we make our application listens for incoming requests on the specific port. We achieve this by using app.listen method. In the example you provided, the code looks as follows: app.listen port, and the callback function return console.log server in running on port. In this line of code, the first argument passed to app.listen is the desired port you want the server to listen on. Additionally, we provide callback function that will be executed when the server is running. In this case, the callback function logs a simple message to the console indicating the server is running on the specific port. To include the value of port variable in log message, we utilize a template string. With our server configuration complete, we can now proceed to run it. To do so, open your terminal and type node index. Assuming your server file is named index.js, upon running this command, you should receive a feedback message from the server indicating that it is running on the specific port, in this case the port 3000. So let's say I want to add the URL of my server to the console.log message. I type http localhost and save it. But nothing happens in the terminal. Why is that? That's because the server is still running in the old version of the code. To see the updated message, I have to stop the server by pressing Ctrl+C and then run it again. Now it's worked. But it's very tedious and time consuming. Fortunately, there's a better way to do this. There's a package called nodemon that can automatically restart your server whenever you save a file. This way, you can see the changes in your code instantly without having to manually stop and start the server. To install nodemon, you need to type npm install --save-dev nodemon in the terminal. The --save-dev means that nodemon is only a development dependency, not a production dependency. This means that nodemon is only used for testing and debugging purpose, not for developing your app in the real world. After installing nodemon, you see it listed under dev dependency in package.json file. Now let's set up the script to run nodemon. A script is a command that you can execute by typing npm followed by name of the script. For example, let's add new script called start and set its value to nodemon index.js. This means that when you type npm start, we're actually running nodemon index.js behind the scene. Now let's try it out. Go to your terminal and type npm start. You should see nodemon starting your server and watching for changes in your files. Now let's make a change in your code and save it. You see nodemon restarting your server automatically and showing the updated message in terminal. Awesome, right? With nodemon, you can save a lot of time and effort while developing your nodemon.js app. When accessing the URL http localhost 3000 in your web browser, you may encounter a message that says cannot get / This occurs because we haven't defined any routes in our index.js file. In the context of Node.js and Express, routing plays a crucial role in handling different requests. To address this issue, let's create our first route using http get method. So let's say app.get in our index.js file. The first parameter of this method specifies the path we expect the incoming request to match, which in this case is the homepage path /. The second parameter is a callback function that accepts two parameters, request and response. Inside the callback function, let's add a console.log statement to test our route. For example, we can log the message we are on the home page now. Additionally, we can use the response.send method to send the response value hello world back to the client. After saving the changes in our index.js file, we can refresh the web page and observe that it displays the message hello world. Additionally, if we check the terminal where our server is running, we will see the logs message we are on the home page now. It indicates that the code within the callback function is executed once when the home page is visited. By implementing this route, we have successfully created a basic response handling for the home page. Now we have better understanding of creating routes. Let's explore 5 different routes for our movie API, which follow the principle of CRUD. C for create, R for read, U for update, and D for delete. This route will allow us to perform various operations on movie data. First, we will implement for post route for large movies, which will enable us to create and add new movies to our collection. Moving on, we're gonna create a get route for large movies. By accessing this route, we're able to retrieve all movies stored in our database. Next, we'll create a get route for large movies /ID. This route is specifically designed to fetch detailed information about a particular movie based on its unique identifier ID. By including movies ID in route's parameter, we can ensure that only that specific movies is returned in the response. To provide the ability to delete movie, we implement a delete route for large movie /ID. This route will allow us to remove a movie from our database based on its ID. Lastly, we will create an update route for large movie /ID. This route will enable us to modify and update the information of the movie in our database. By providing the movie's ID as a parameter, we can determine the movie that needs to be updated and make necessary changes. To organize our code better and avoid cluttering in index.js file with multiple routes, we can create a new folder called routes, and within it, a file named movie.js. This file will handle all the routes related to movies. Similarly to the index.js file, we need to import Express module. This allows us to utilize the functionality of Express within this file. Next, we create a new router instance by calling express.router. This will create a modular and isolated object specifically for the movie routes. Here how we can do it. const router equal express.router. Now we can define our first route using the get method. For example, we can have a route for the path /movies that simply send the response hello. With express, we can define this route using the following code. After defining all necessary routes, it's crucial to export the router object so that it can be used in other files. In Movies.js, we can export the router. Now let's go back to index.js file. We need to import the movie routes by including the following code. Importantly, make sure to include the .js file extension to ensure the correct file is imported. To use the movie routes in our application, we can add a line app.use /movies movie routes. This code sets up the movie routes to be used under the base path /movies. By doing so, we can concatenate the /movie path defined in the movie routes file with any subsequent routes specific to movies. With our movies route correctly set up, we can now visit localhost 3000 /movies in our web browser and observe the message hello being displayed at the response. By creating a separate movie.js file within the routes folder, we can improve the readability and maintainability of our code. Now I have prepared a movie.json file containing information about various movies, including their name, director, genre, and release year. Please note that this is a JSON file, so the properties names are enclosed in the double quotes. You can find this JSON file on my GitHub, which I put the link below the description. To retrieve all movies from the JSON file, we can send a GET request to the /movie endpoint. In the movie.js file, we import the fs module to read the contents of the movie.json file. We then parse it into JSON object using json.parse. The readFileSync method is used with the path .movies.json. And the UTF-8 encoding, the resulting data is stored in the movies variable. Let's break down the line of code for a better understanding. This part of code uses the readFileSync method from the fs module to read the contents of the file named movies.json. The UTF-8 parameter specifies the character encoding to be used when reading the file. The json.parse function is used to parse data read from the file. It takes a string as an argument and converts it into a JavaScript object. The resulting parsed JavaScript object from the JSON file is assigned to variable named movies. Now you understand it. Let's move on. At the get method, we respond with the response.sendMovies. After saving the changes and refreshing the web page, you will see the response displaying detail of 10 movies. So far, we have learned how to make a GET request. But to learn about another request, we need to install the software that helps us to test our API. This software is called Postman. To download Postman, go to postman.com and click on the download button. When you have installed and opened Postman, you will see a window like this. To use Postman, click on the plus icon at the top left corner of the window. In the URL field, enter the localhost 3000 and make sure that the request type is set to GET. Click on Send and you should receive a response of "We are on the home page now." Now let's send a GET request to the /movie endpoint by entering /movies in the URL field and click on Send. You should receive a response containing all the movies in our database. But for example, your database doesn't have any data at first, How can you generate data? Well, you can use post request to post data and store it on database. That's why we're learning about the post request now. In Movies.js, delete the movie object so that our website doesn't get any data at first. In the writer.post method of Movies.js, we need to add a console.log statement to verify if the callback function was executed successfully. Additionally, we should include a response.send statement to send a response back to the client side, confirming the successful post, let's say the 5, and return to Postman to test it. In Postman, to send a post request, click on drop down next to the URL field and select post. We need to move the params to body. Click on raw and change the format from text to JSON. You enter information about new movies in JSON format and click on send, and you will see the response display indicating a successful post. In the terminal, you will also see the same message from the console log. However, for now, we will continue working with mock database instead of interacting with actual MongoDB database. When we work with the post request, we have access to the request body through request.body. To see the contents of the request body, let's add the console.log statement console.log request.body. This will allow us to view data hidden inside it. Save the file and restart the server. Send the request again. If I look at my terminal, the value of request.body is undefined. This happened when you forgot to set the content parsing middleware before registering your route handler function. To solve this problem, in index.js, you need to import body parser from body-parser. Next, register the body parser middleware here. Notice the call to app.use bodyparser.json should be at the top of your file before registering any route handlers. This content parser module allows us to parse incoming request bodies in the middleware. Go back to Postman and resend the post request. You will get the movie info in request.body. Now you see the full object display. It's stored in the request.body. Next, let's store the movie object from the request body in a constant variable. Const movie equal request.body. Now that we have the movie object, we can push this to our existing array called movies. Let's create a new array called movies. Use the movies.pushMovie. This statement will add a movie to the array. To send response back to the client side, let's use the response.send method. We can send a message like movie.movie_name. Movie has been added to the database. Save the file and send request one more. You will see the response message display. Dark Knight movie has been added to the database. The next step is to obtain the details of single movies. To do this, we need a unique identifier. This is different from on other movies. Using the movie's name as an identifier is not feasible because in our cinematic history, there are many movies with the same name. For example, The Lion King 1994 and The Lion King 2019 are different only in their release year. Another example, you create a database for user. It's impossible to use their name as a unique identifier. I mean, maybe there are two people who have the same name. Therefore, we need to use a package called uuid from npm. You can run the npm install uuid on the terminal. And after that, you scroll down on the web page to see how to import it. By calling the function uuid v4 you will receive a unique number. This is never going to be the same as any other string. This string has many versions, but we use version 4, which is randomly created from cryptographically strong random values. In the Movies.js file, we import the UUID model, as well as move this function to the post request. To add this ID to the movie arrays in the post request, you can use the spread method like this. Make sure you understand the spread method in JavaScript if you haven't learned about it yet. You can read more about it on W3 School. In the get method, let's say response.send movies. So let's restart our server and send a post request again. Then you make the get request and see. We do have the Dark Knight movie with the ID of some random number. Let's try to post another movies. Let's say movies name, inception, director, genre, and release year. And make a get request again. We can see we have two movies now with different ID. To create a new route that shows detail of specific movie by its ID, we can define a get route with parameter name ID. The route should look like this. In this route, we use the colon sign ID to indicate that it is a dynamic parameter and can accept any value. For example, if we visit /movies/ID, we should see the message, the get ID route. Even if we enter a different value after /movie such as /movie/TK or /movie/ a random number, the route will still work and display the same result. This is because the colon sign signifies that we are expecting any value after /movie/path, and the route will be triggered accordingly. To set the value of dynamic parameter, we can use the request.params. For example, to print the value of ID parameter on the page, we can use the response.send the ID $curly bracket request.param.id. We can also log it using console.log request.params.id. After making these changes, we can refresh the page in the browser and see that we successfully get an object with ID value display. We can try entering different ID, and each time it will work correctly. Now instead of just sending an ID value, we want to send a movie data for a specific ID. To achieve it, we need to find a movie in the movie array that has the same ID as the one we are looking for. To do that, we can use the find method on movies array, movies.findMovie, take the movie as an argument, and return movie ID request.param.id. This code will search for the movie with the ID matching the ID specified in the route parameter. Then we consider this block of code as the file movies constant variable. And right here, let's say response.send file movies. Let's see if that works. Go back to the web page, specifically the /movie routes, and you will notice that there are no movies displayed at the moment. This is expected since we haven't added any movie yet. Now let's switch to Postman and make a post request to add a movie called Inception and another movie called The Dark Knight to our movie collection. After adding the movies, if we refresh the /movie routes, we should see that the two movies are now listed. each with a different ID assigned to it. If we copy one of the movie's ID and append it after the last movie last in the route, we should be able to see the details specific to that movie only. Not only we can retrieve details for a specific movie using its ID, but we can also use the ID to perform another operations, such as updating or deleting the movie. Now let's implement the delete functionality. We'll create another route using the delete method and specify dynamic parameter ID in the route path. This route will be responsible for deleting the movie with the specific ID. Inside the route handler function, we have access to the request and response object. Now we can add a logic to delete the movie that corresponds to the specific ID. Now we need to remove the specific movie from the movies array using its ID. To achieve this, we can use the filter function. The filter function takes a callback function that is called for each movie in the movies array. If the callback function returns true, the movie is kept in the array. If it returns false, the movie is removed from the array. In our case, we want to keep all movie except the one whose ID matches the ID we want to remove, so we compare each movie's ID to the ID we have in request.params.id. If they're not equal, the callback function returns true and the movie is kept in the array. But if they're equal, the callback function returns false and the movie is removed from the array. To inform the client about the deletion, we can send a response with message, indicate that the movie with specific ID has been deleted from the database. After making these changes, let's test the functionality in Postman. First, make some post requests to add several movies, such as The Dark Knight and Inception. Then make a GET request to verify that the movies are listed correctly. To delete the movie, retrieve its ID in the request URL, append /movie/ followed by ID of the movie you want to delete, and switch the request method to delete. After sending the request, you should receive a response with message, movie with ID has been deleted from the database. Finally, make another GET request to confirm the movie has been successfully removed from the database. Now you still see that the previous two movies are still in the database. What's going on? So let's go back to the Movies.js file, focus on this line of code. The filter method in JavaScript does not change the original movies array, so that's why we cannot remove the movie we need from the database. To solve this problem, just override the original movie array like this. I'm very sure it will work, so let's check it out. Switch to Postman. Again, I will post to movie with the URL /movie/. Then I make GET request to see if our movies are listed correctly or not. Next, I want to delete the Dark Knight movie, so I will get its ID. In the URL field, append /movie/ followed by the ID and make a delete request. Now you can see we successfully delete the movie by its ID. To update a movie, we use the patch request, which is used when we want to partially modify something. Let's set up the route router.patch. In this route, we specify the dynamic parameter ID, since we need to know which movie we want to update. We have a set to the request and response objects. To update the specific movie, we first need to find it. We can use the find method on the movies array, similar to what we did before. Once we have found the movie, we can proceed with the patch request. In this case, not only do we need the dynamic ID, but we also need to specify the specific information we want to update. For example, in the Postman, now we have the Dark Knight movies in the database. We switch to the patch request. We can send an object in the request body containing the field we want to update. For instance, movies name The Dark Knight Rises. After that, appending the movie ID to large movies in the URL field. Now in our code, we can receive the update movie information from the request.body. We can destruct the field we need, such as movie name, director, genre, and release year. To update the movie, we can use the simple if statement to check if the field is not empty, indicating that we have a new information to update in the request.body. With this code, we can change one or more different properties of the movie. Finally, we can send a response indicating that the movie with the specific ID has been updated. After making these changes, let's test the update functionality in the Postman. First, use the post request to create a new movie, such as The Dark Knight. Then make a GET request to retrieve the movie ID. Copy the ID and use it in the patch request URL. In the request body, including the field we want to update, such as movie name The Dark Knight Rises. After sending the request, you should receive a response indicating that the movie with the specific ID has been updated. You can make a GET request to large movie large to confirm that our movie has been updated correctly. Our application is nearly completion, but in the Movies.js file, there are not only routes. While we do have routes, these routes contain a lot of logic. It may be easy for you and me to understand because we have watched this project being built from scratch. However, if our project becomes more complex and has more routes, other people who look at it will be confused. To address this, we should try to separate the logic from the routing. People often create a folder called controllers for this purpose. Inside the controller folder, you can create a file named Movie.js. Let's start by working with the post route. The post route has two parameters. The first one is large route, and the second one is callback function that will be executed when someone makes a post request. We can take the callback function and separate it into a new function called createMovie. So if we pass a callback function inside the createMovie function, we now have a separate function called createMovies. Now we can take this function and extract it into a separate file. That file will be the Movies.js inside the controller folder. Inside it, we only need to export the createMovie function. Here, you notice that we have not defined the movie variable in this file. It's very simple. I just need to move this line of code from here to here. Next, we go back to the routes, and at the top, we import the createMovie function like this. Now, as you can see, we're using this function. I would like you to do the same thing for on other routes. Let me show you how to do it with a few more. For example, get movies, get movie, delete movie, and update movie. Here you can see, again, we have not defined the UUID v4 function yet. Just like the moment before, we move this line of code from here to here. Now save the file and wait. I got an error message. Cannot find the module. Oh, my mistake was missing the JS file extension. Okay, save the file and everything is okay. You can see how simple this looks now. We only have the routes here, but they're telling us so much more because of the semantic function names we create above. Now, when we see large movies, we know it is function responsible for getting movies. When we want to get a movie with a specific ID, we have the getMovie function. If we want to delete a movie with specific ID, we call the delete function. You can see that the functions are actually in the controller folder. That's great. Now let's give our application one final test by going to our localhost and see if everything works perfectly, because we make a lot of changes. Starting with the browser, if we make the get request to large movies, we see an empty array. Now let's use Postman to make a post request and create a few movies, such as The Dark Knight, Inception, and The Godfather. After creating the movies, we come back to the browser, refresh the page, and see all 3 movies in the database. Now let's try accessing the information for the specific movie. We can take the ID of the movie and visit large movie large ID. By doing this, we will only get the information for that specific movie. In the Postman, let's try deleting a movie. We can make a delete request and provide the movie's ID in the path. After running the function, we can see that the movie with ID is deleted from the database. If we go back to large movies and make a get request, we can see that we only have the remaining movies. The last thing to test is if we can actually modify a movie. To do this, let's make a patch request to the specific movie ID and modify it by sending some data, such as changing the release year to 2010. After saving the changes, you can see that the movie with ID has been updated. If we go back to the large movie route and make a get request, we can see that the movie has been updated. This confirmed that our update function worked perfectly. And there you have it. This is the full application. As you can see, the file structure is not that bad. We have the index.js file for setting up server, the routes for handling routing, and the controllers making things work and adding the logic. Thank you so much for watching, and I will see you in the next video.